A plane travels at a bearing of 153 degrees from point A for 63.7 miles. So first, we need to be able to draw an x and y-axis, since it's doing a bearing or a direction of 153 degrees. So therefore, I'm going to place as dash. This is my y-axis. And I want to make a large drawing if possible. If you want to go and draw on a separate piece of paper, that might be a good idea, just so we can make a little larger drawing than the space that's provided. So this is point A, this is your starting point. And whenever we're doing bearing of 153 degrees, we are going from the north towards the right, 153 degrees. So therefore, I'm going to start from the north towards the right. That's 90 degrees. I need 153. So therefore, I'm going to divide this in 3 sections. So this will be 120, 150, and a bit more. You want to make sure that you make an accurate drawing, if possible. And the most accurate drawing that you draw, the better you'll be. And you want to make a large drawing. So let me go and make this a little larger. This angle is 153 degrees. And it travels for 63.7 miles. So this side is 63.7 miles. The plane travels due north for 23. So then after, once it's located here, it's going to travel straight up north for 23. Notice that this side is going to be shorter, since the first side is 63. I want to make sure that I make this one shorter than the 63. You want to make an accurate drawing. It doesn't have to be perfect. Therefore, this will be 25.3 miles. How far is a plane from point A? So this is the current location. So we are going to find this length, which will be x. Now, you will be having 2 right triangles because I need to be able to find an angle. Now, a good indication is that you're going to have to find the angle between both sides. So that way we can use the law of cosines. I'm going to continue extending this because this will be one of the triangles I can use. So either this triangle here will help me find an angle, or this triangle here is also going to be a right triangle. Either one of those 2 triangles is going to help me find one of the angles. So therefore, let's look at this side. I'm going to be able to determine the angle, this angle here. If the angle stops right here, then I'll be able to determine this angle here. But then since this angle continues all the way over here, I cannot know what this angle is. So am I able to determine the measurement of this angle? Yes. Since this is 153 degrees all the way up to here, all the way through will be 180. So therefore 180 minus 153, this angle here will be 27 degrees. And from there, we can find this angle. Since this is a north and south line, and this one as well, we know that those 2 lines are perpendicular. So therefore, if this is 27, this will also be 27 degrees. Or if you want to go through the process and say, well, this is a right triangle. So therefore, I know that all 3 sides are equal to 180. So therefore, if this is 27, this is 90. Added together will be 180. So therefore, this is 63. This is 53, 63. And since this is also a right angle, and this is 63, this will be 27. So therefore, now we have two sides and the angle in between. So therefore I can find x. And I'm going to use my law of cosines. So that'll be x squared is equal to one side, 63.7 squared, plus the other side, which is 25.3 squared, minus 2. I'm going to multiply this side once again, 63.7 and 25.3, multiplied by the cosine of the angle in between, which is 27 degrees. And from there, I'm going to go ahead and type it into my calculator, and that will give me my answer. So hopefully you're typing it in your calculator as well. And you can type everything in at once since there are no variables. And make sure that you have your calculator on degrees. So therefore this is x squared is equal to 1825.86. And I want to leave that into my calculator. So I'm just going to take the square root of my answer. So that way I have a more exact answer. So therefore x is equal to 42.7. And in this case we're talking about miles. And that'll be your answer. That is how far is the ship now from your starting point.